Our next section is about linear functions. So I'm going to introduce something that you're going to see in pretty much every other math class you ever take, and it's called function notation. So function notation you will usually see written as f of x. And that's actually what I will say when I say this out loud, and what you should say when you say it out loud. We refer to this as f of x. So that's what this thing is. We call that f of x. And they don't always use the letter f. You'll sometimes see other ones, and I'll show you one or two others. But the one thing I do want you to know is that f of x is it's kind of a fancy way to write y. So f of x is another name for y. And the number one mistake I see that I want you to know is that this is not the same thing as f times x. So please, please, please don't think that parentheses means times. So function notation, like I said, it's a fancy way to write your variable y. So I'm going to give you some examples to start with. And for our first set of examples, I am going to ask you to find the value of f of x equals 2x minus 10 when we're going to have three problems. The first one is going to be when x equals negative 3. So what I'm going to do is I am going to take my equation, f of x equals 2x minus 1, and I am going to substitute that negative 3 in for every x. So this part will sometimes confuse people because it still looks like I have f times 3, but I don't. So we're going to write this as f of 3. We keep it written like that, as f of 3. We write that as f of 3 equals 6 minus 10, which is going to give us negative 4. Now, if you want, as you're doing these problems, on this particular type, if you want to rewrite the whole entire equation as y equals 2x minus 10, and then write your answer as y equals negative 4, that is completely okay. However, you do need to know the notation, that you do need to know that that means f of 3 is the same thing as the value of y when x equals 3. So you can do it that way if you want to, if it makes you feel more comfortable. But on our second set of examples, you are going to have to actually use the notation. So we're still going to keep on with the same one. This time I want you to try these two on your own. And so go ahead and pause. I have x equals negative 1 and I have x equals 10. So pause and try these. Okay, for B, we're going to take our equation, f of x equals 2x minus 10. I'm going to rewrite this as f of negative 1 equals 2 times negative 1 minus 10. 2 times negative 1 is negative 2. So I end up getting the answer of negative 12. For the next one, I have x equals positive 10. I'm going to substitute that in for x. I end up getting 2 times 10 minus 10. 2 times 10 is 20. 29 minus 10 is 10. So that's my answer for that one. So the next type of example, I'm going to give you g of x. It is the same type of notation. It's still function notation. The only difference is that I changed the f to g. It's just the same thing, different letter. Don't let that scare you. It's not any different. So for g of x equals 3x minus 1, we're going to find three things. The first one is g of 8. The second one is g of negative 2. And the third one is g of 0. If you know what to do, you can feel free to do it on your own. However, I do want to go through the problem. So what they did here was they took this x in the g of x, they replaced that with an 8. So what you're going to do is you're going to take the x in the original problem, you're going to replace that with an 8. We end up getting 3 times 8 minus 1, which gives us 24 minus 1, and the answer is actually going to be 23. So for that problem, it looks a lot harder than it is. Just remember that it's not g times 8, it's g of 8. It just means that you're going to set x equal to 8 in all of these. So go ahead, try B and C on your own, pause it. Okay, so for B, you should have gotten that g of negative 2 gives you 3 times negative 2 minus 1. Negative 6 minus 1 is negative 7. G of 0 gives you 3 times 0 minus 1, and your answer is just going to be 0 minus 1, which gives you negative 1. So 1 and 2 are the same type. 3 is going to be kind of the opposite idea. For the third type of problem, I'm only going to give you one. And in this one, I'm going to say for the function h of x equals 2x plus 4, we're going to find the value of x so that h of x equals 16. So if you get a problem like this and you're on a test and it's really confusing you, you might want to change these h of x's to y's because it's just another, like I said, it's a fancy way to write y. If you want to do that, you can. However, I'm just going to keep it as it is. So we have h of x equals 2x plus 4. They tell us that h of x equals 16. So what that means is in for the h of x, this whole entire thing, not just the x, not just the h, but the whole entire thing, I'm going to put in 16. Now I have an equation just like the ones that we solved back in the last chapter. So now I can just solve this one like I would normally solve. So I'm going to subtract 4 and then divide by 2. And I do get that x is 6. Our last type of problem involves graphing. And now, this one looks hard because we have the f of x in it. However, it's actually the exact same thing that you did in the last chapter. So remember, once again, f of x is a fancy way to write y. So actually, all we're going to be doing is graphing y equals 2x minus 3. I would like you to pause and try it on your own. So when you do this, you get that your slope is 2. I'm going to write it as 2 over 1. Your y-intercept is at negative 3. So what I'm going to do is I'm going to start my y-intercept at negative 3. I'm going to go up 2, write 1, and then draw my line through it. And that's it.